This is a 20-watt audio amplifier, apparently. The only strange thing is, it's tiny. The thing that strikes me funny about this is that obviously this is going to be a Class D amplifier, but I'd normally expect to see inductors, larger inductors and capacitors on the output. I think we do have these tiny surface mount inductors on here and capacitors and various other support circuitry. The chip's labelled OEP20W. Googling about finds that sort of cross-references to a Texas Instruments TPA3001D1, which is down as a 20-watt Class D power amplifier. So in theory I should be able to hook this up to a source, a power supply, and it's rated for 8 to 18 volts, I think it was. It does say on the back. 18 volts to get you 20 watts. 12 volts will give you 9 watts. It depends on the impedance of the speaker and the input voltage. So anyway, let's get some wires hooked up to this and see if it works, and if it does work, if it sounds okay or terrible. Obviously it's not going to be hi-fi grade, but might be useful for something. Okay, so I've soldered some wires to it and attached it to some connector block just to make things a bit easier to wire stuff to. I've attached some power leads. I've got my bench power supply set to 8 volts, which is its minimum working voltage. Current limit set to 50 milliamps. This meter is on current mode of the probe. I'm just going to poke this in the positive terminal of my power supply and see what current it draws. So I've got no speaker and no input connected at the moment. There is also a pin marked CS, which I don't know what it does. I'm guessing it's a muting pin or something along those lines. So let's apply power and see what we get. 6 milliamps. Voltage is holding stable at 8 volts. So let's try connecting up a speaker and see what happens. Okay, so I've attached a speaker. The only speaker I've got is this pendant speaker, but it's designed for 100 volt line, but it does have an 8 ohm mode on the switch. Power supply is still set to 8 volts, still current limited at 50 milliamps. So let's connect the power. I heard a pop from the speaker, and let's see if I probe the input. We can just touch my finger to it to see if we get any sort of noise. I'm getting noise, so it's obviously doing some sort of amplification. So what I want to do is check and make sure there's no voltage on the input, just in case, because I don't want to connect an input device to it and find that I kill it because there's voltage across the input. So right, that's probing across the input, and I'm getting 0. So I think we're good to go. Let's try hooking up a source. Okay, so I've got a source hooked up, little DAB radio. First thing I've noticed is this is still powered on, still at 8 volts and still limited to 50 milliamps. However, watch what happens. This is the signal meter. Watch what happens when I turn the power supply off. Immediately the signal increases. So this makes me think it's creating a lot of electrical noise. I'll power back on. Now normally I can get a full signal on this radio with the antenna down, but I've had to put the antenna up just to get this half signal, but it's above the marker there, so it's good enough to play. Now let's crank the volume up a little bit and see how it sounds. That's about as loud as I can go without it clipping, because the power supply starts current limiting. So that's actually reasonably loud. No, perfectly listenable, and that's, like I say, it's limited to 50 milliamps. So you can imagine that this is a very efficient amp. That's a 20-watt speaker. So it's interesting if I touch the amplifier as well. It's not doing it now. Earlier on I had it making some strange noises when I touched it. So let's increase the current limit. Oops. I don't know what's happened. It suddenly stopped. It must have gone into a shutdown mode or something. Well, that's pretty amazing. So let's try increasing the voltage and the current. Okay, I needed an audio source with a little bit less susceptibility to RF, so I've chosen my old mini disc player. It's queued up and ready to go. I have the disc paused and the volume right down at the moment. So what I'll do is I'll turn the volume up to 5 and push play. It's playing. Right, I've limited the current to 150 milliamps. And we're on 12 volts now. So you can see 12 volts. If I go up too high with the volume, the current limiter starts kicking in. There's a lot of bass in this song. It's hopefully not got a copyright strike. It's from an Amiga game called The Shadow of the Third Moon. It was a CD audio track from the game. Oops, I've gone too far. Reset. That's loud. That's very loud. That's amazing. From that thing, is it hot? No, it's cold. Let's crank the current up a bit more. Too much. Reset. Well, I'm officially amazed. That's unbelievable. That tiny thing kicking out all that sound. The floor is vibrating. I'll send a link to this, put a link to this in the description. It costs £1.22 delivered straight from China. I can't believe that. That's crazy. Amazed how actually clear. It's not perfect, it's not exactly super high quality audio, but it's certainly acceptable. Apparently it'll take up to 18 volts, and at that it will produce about 20 watts. That's quite impressive. Anyway, that's enough of this. I'll send a link to the item in the description, and yeah, you could use this to build all sorts of little projects, little audio projects. Very efficient. It's hardly using. If I put this on current, start this song again. It's hardly touching. This is 1 amp there. We are on the 1 amp scale, I think. No, we're on 3 amp scale. Okay, that's 1 amp now. Just waiting for it to kick in. It's gone above the limit there. Let's turn the limit all the way up. That's as loud as the business player will go, so that's full blast. That's too loud to comfortably listen to from that. That's crazy. Oh well.